We first started planning our project in Milestone 1. We brainstormed problems that the elderly face and thought of robots that would help solve each problem, including the inputs and outputs that each would use. We narrowed down these ideas until we finally came up with Project Smith. Smith notifies you when it's time to take medicine, keeps medicine secure unless an authorized user is trying to take it at the right time, then presents each medicine and dosage one by one.
So for our hardware, we're using two Arduino boards. For inputs, we have a button to start the program, a button to dispense water, and a button to change time. We also have a fingerprint scanner to scan the fingerprint of the user. For outputs, we have a buzzer to notify when the medicine is to be taken, and an LED to simulate water, a display to display messages to the user, and a servo to reveal the right medicine.
We ran into several problems along the way when we tried to integrate the whole project. The first problem we ran into was that our servo didn't work with our fingerprint scanner or buzzer. We don't know why, but these components glitched when they were on the same board. We also ran into issues with memory. The library for our display and fingerprint scanner both use around 80% of a single board's memory. Therefore, we couldn't run both sensors on a single Arduino. We solved this problem by using two boards. The main board, or the master board, had the fingerprint scanner and the buzzer, while the second board, or slave board, had the display and servo. The two boards communicated through what is called an I2C connection. Through this connection, a single master board can have over 200 slaves. However, our second board had to act as both a slave and a master to work properly, which caused us issues. In the end, we were only able to use our display to display some initial info.
Our code is split into two different programs. Program 1 runs on board 1 as a master device. This does most of our logic in our main state machine and transmits a 2-digit variable to board 2, which is our slave machine. Board 2 runs program 2 and decrypts this 2-digit integer and splits it up into single-digit integers. These two variables determine servo position as well as what needs to be outputted to the serial monitor.
Our system is comprised of 3 buttons, the first of which simulates the time of day. Button 1 starts the simulation. Once pressed, you'll hear an alarm followed by instructions to place your finger on the fingerprint scanner. Once recognized, the servo will spin to the medicine that you need based on the time of day. The serial monitor will then tell you how much water to take from the built-in water dispenser. Once the water is dispensed, the servo securely locks to protect your medicine for later use.